could artificial intelligences be conscious? Are they human? So, what are the limits of the machine idea? Are we just machines, or are we something more than machines? And I thought that it seemed an intuitively good way to go after this.
Welcome back, everyone, to the Smarter Not Harder podcast, your home to 1 cent solutions to life's $64,000 questions. And today, I'm not sure that $64,000 would actually be the right number to the question that we're asking. I'm one of two hosts today. Dr. Ted is joining me as well. And our guest today is Donald Hoffman. And for those of you who aren't familiar with Don's work, let's jump right into a little bit of his bio. He's an American cognitive psychologist and popular science author. He is a professor in the Department of Cognitive Sciences at the University of California, Irvine, with joint appointments in the Department of Philosophy, the Department of Logic and Philosophy of Science, and the School of Computer Science. Don studies consciousness, visual perception, and evolutionary psychology using mathematical models and psychophysical experiments. He's the author of The Case Against Reality, and his TED Talk, as of the recording of this episode, has over 4.6 million views. So what did we get into in this conversation? It was just absolutely fun to be a part of, really just watching this intellectual conversation between two juggernauts. We got into how Donald really started studying consciousness. We talked about conscious agents having an experience, the Amplituhedron, is reality delayed, and what do we mean by that? Don's battle with COVID, his thoughts on psychedelics, and so much more. This is one where I encourage you to listen through all the way to the end, because a lot of explanations come in due time, but pause as needed, Google as needed, and of course, read Don's book, The Case Against Reality. Let's get started with the episode. Don, it's so awesome to have you here on our show today. I know personally, I've been looking forward to speaking with you for a very long time. You and Ted have spoken before, so welcome to our show.
Thank you very much, Boomer and Ted. Great to be with you, and thanks for the kind invitation.
I wanted to start things off with something that occurred to you recently, and maybe it's just fresh in my memory because I got COVID last week. But I want to go through your experience with getting COVID, what it was like, and you can tackle this however you want, what it was like for you and how it made you question some of the things you'd been working on or what you believed up until that point.
Well, yeah, apparently I got it in January of 2020. So before we even had the name for it, I was teaching a couple of international classes at UC Irvine. And so a lot of the students had come in from around the world, and many of them were coughing and hacking and so forth. And 2 weeks into the quarter, I got something that was unbelievably nasty, and didn't know what it was. Just thought it was a really bad something or other. So I managed to struggle through it and keep on teaching. I sort of just kept myself together. But then I noticed when I was working out, my heart started acting up, started failing when I was jogging and so forth. And it got worse and worse, and finally got to the point where it just about killed me. I was in an emergency room with my heartbeat at like 180, 190 for 36 hours. And so at that point, I said goodbye to my wife, texted her goodbye. And fortunately, they were able, with one of the drugs finally worked, and they got the heartbeat down, and we were able to keep me going until they could get me into a surgery. Because of COVID, there was a backlog on the surgery, so it wasn't really clear to me that I was going to live long enough to get the surgery. And so that kept it quite interesting for many weeks.
What was the surgery for?
Well, so the problem, was a cardiac ablation.
Okay.
So apparently the virus went in and attacked the lining of the atria, and
Yes.
There were 33 different spots that they had to kill. They had to burn or freeze.
Yes. Yeah.
That's a lot. So it was pretty extensive damage that had been done. And but the doctor was thorough. It took like 4.5 hours. So it was under for 4.5 hours because there was so much that they had to find and destroy. And then the recovery, basically it took me out for a year. The recovery itself was, I basically didn't even do anything on Twitter for 9 months. And after 9 months, I went back on and said sorry for the long silence, but it was just about staying alive for the last almost a year. So that was really quite a shock to the system, and the drugs also that I had to take were didn't agree with me. So
Okay. You have a lot of side effects, and I
well,
hope you didn't get brain fog from long haul COVID, or
fortunately not. It apparently went for my heart and not for my head. My wife right now has brain fog from COVID.
okay.
So
I
it's
thought you were going to attribute that to Gödel's incompleteness theorem,
uh,
but it's just brain fog.
right. No, I'm delighted that it didn't do that. I have good friends in academia though, where of course mental clarity is the coin of the realm, and some of them have
Yes.
ended up with brain fog, and so it's quite devastating to them and their careers. So I really have empathy for that. So yeah, it was funny because I didn't know what it was when I first got it, and it was months before we even had a name for this thing. So, but we know now that it was here in the United States before January of 2020, and so it's no surprise that I got it with a group of students that had been around the world and had just flown back in to take my class or take classes,
Mhm.
not mine, but classes in general at UCI. So
We're going to get a lot into consciousness and your work over the course of this conversation. And before we get into that work, and what I would love to do is just hear from you, what shaped the desire to research consciousness and reality, because you grew up the son of a minister,
right.
and that, to me, there's probably some dissonance that at some point needed to be wrestled with. So what allowed you to arrive at the point where you wanted to do all of this research?
Right. So yeah, my dad was a minister and they were heavily into fundamentalist Christianity from about the time I was 9 or 10. And so church on Sundays, and also they did Wednesdays and all things like that. So there you would get one story about reality and one attitude about facts and faith and reason. And at the university, well, not the university, but at high school and so forth, the junior high, I would be getting a different kind of story. And so the question that came to me was, okay, well, how do I figure out what's going on here? Because I'm getting different pictures from the two different groups. So that put me on a quest to really decide for myself. And I was interested, in computers at the time. I was interested in artificial intelligence. And so for me, I was able to frame what I thought was a precise way of looking at this, which was, could artificial intelligences be conscious? Are they human? So, what are the limits of the machine idea? Are we just machines, or are we something more than machines? And I thought that was it seemed an intuitively good way to go after this. And I thought about philosophy, but I eventually did a degree in quantitative psychology at UCLA, which was like a major in psychology and a minor in computer science and applied mathematics. So I really wanted to cover the bases. And so as part of that, for example, I had to write a compiler for a programming language. That was part of the curriculum. So it was quite wide ranging curriculum. And so I really got a good chance to dive into the empirical work in psychology and the good theoretical work in computer science and of course the mathematics. My last year at UCLA, I took a class where we studied artificial intelligence. I was a senior, but it was a grad class, and the professor kindly let me in, which was wonderful because I was then exposed to all the state-of-the-art literature, and in particular to the work of David Marr, who was this young guy at the time at MIT, was not even
Vision,
35 years
right?
old.
Vision. Yeah.
Yeah, and
His
vision.
his work was on vision.
That's right. So his PhD had been in the neurophysiology of the cerebellum. So he was a neurophysiologist PhD, but his master's was in mathematics. But he went to MIT and was part of the artificial intelligence lab there because he realized that the neuroscience needed to also be complemented by an understanding of the computational processes and the reason for the computational processes. So it wasn't enough just to know the circuitry of the brain. You really needed to understand computationally what was going on. And so when I read Marr's paper as part of this graduate class at UCLA, I said, who is this guy and where is he? This is exactly what I want. I mean, no nonsense. His attitude about vision was build one. If you think you have an idea about how vision works, don't come to me until you've built one. And when you have built one, then you have something to say. Otherwise, this is just hand wave. And I really like that attitude. Let's get rigorous enough that we can build working systems. And so I found out he was at MIT, which was a surprise. I thought, physics, engineering, but not psychology. But he was in the brain and cognitive sciences department now, and also the AI lab. So I was lucky. I got to go to MIT, and I was in both the AI lab and the brain and cognitive sciences department, and got to work with Mark. Unfortunately, he died of leukemia. I got to work with him, I don't know, a year and a half or something like that, and then he died. But so it was quite a tragedy. But I feel very lucky that I got to work with him for that time, because even as impaired as he was with the leukemia, he was brilliant, and so I learned a lot from him, and he had assembled a wonderful team there. So I got to then really jump in and look at the question, are we really machines? And to do it by studying visual science and being, I wanted to study consciousness, but I figured that was, that's biting off a bit much. I was young. I needed to learn.
It doesn't get funded.
Yeah,
it doesn't get funded.
It doesn't get funded. Vision was fun, and I figured I could really learn a lot of technical things by focusing on vision. And so I did that, but almost as soon as I finished at MIT and I got a job at UC Irvine on the faculty and cognitive science department, the closer I got to tenure, the more I was interested in branching out and looking at consciousness itself. So after I started working on a theory of perception, but in a mathematical model of it, and we published it. It's called Observer Mechanics. So with Bruce Bennett and Chetan Prakash, we published a theory of perception, but it really is a theory of consciousness. Right. But back then, it wasn't really kosher to talk about mathematical models of consciousness. So we called it a theory of formal theory of perception. But it really is about experience and conscious experience and how they evolve. So we published that in '89. And I continued to work on vision because vision is, in some sense, the place where consciousness research has focused, because we have the most data in vision. It's easy to do experiments there. We know a lot about the physiology. So if we're going to try to figure out the relationship between brain activity and conscious experiences, vision is nice because it's in some sense easier than a lot of other areas, and we have a lot more tools. So I worked on that for quite a while, but then I decided to use evolutionary theory and asked the question, are we machines? And are we biological machines from a deeper point of view? Because I began to think from the math I was working on with Bruce Bennett and Chetan Prakash that maybe space and time and physical objects aren't fundamental, right? The math was hinting at that, but having the math at least be compatible with that is different than saying that we have a theory that suggests that, right? So I decided I would look at evolution by natural selection. This was in the mid 2000s, 2006, 2005, something like that. I thought, evolution tends to do things on the cheap, and it tends to use tricks and hacks. So, maybe I would find that there are, some cases where we don't see reality as it is. Doing things on the cheap sometimes isn't compatible with seeing the truth. So
it's like mating with a beer bottle, right?
Yeah, exactly. Like the Blue Beetle. That's right. That's right. And there's all sorts of examples like that of supernormal stimuli that can fool us and fool other creatures. Yes. So I began to look at that and got a couple of wonderful graduate students, Justin Mark and Brian Marion, and Kyle Stevens and some others who didn't work directly on the mathematics. Darren Peshek worked on some experiments related to this. And what their simulations showed really stunned me. Yes, evolution does things on the cheap, and yes, that will tend sometimes to make you not see the truth. But it was deeper than that. This is where actually doing the work surprises you. So it came out much, much deeper. And the real eye-opener to me was that fitness payoff functions, which are sort of the heart and soul of evolutionary game theory. It's games. Evolutionary game theory turns evolution into a mathematical process. It's like a game where you're competing for points, but these are fitness payoffs. And it turns out the theory of evolution by natural selection entails that there are these fitness payoff functions, and it only entails that one of these payoff functions, one property of the world must be preserved by these payoff functions, and only one is required by evolutionary theory. It requires that the probabilistic structure of objective reality, whatever that reality might be, has to be non-trivially related to the probabilistic structure of the payoff values. If it were not, then no science would be possible. So this relationship is called a measurability relationship. So the payoff functions have to be measurable functions. But other than that, there are no restrictions. And what we discovered, and this is work with Chetan Prakash, Manish Singh, and Chris Fields, and Robert Pretner, and others, we discovered that payoff functions, the probability that a payoff function preserves any structure that you're interested, like a total order or a topology or a metric. It's straightforward to prove, especially if you have a mathematician working with you. It's straightforward to prove that the probability is zero that a randomly chosen payoff function will preserve any specific structure of the world. And that means, in layman's terms, payoff functions do not contain information about the structure of the world. And so when evolution tunes sensory systems to payoff functions, they cannot be tuned to the structure of the world. That information is just not there. And that blew me away because it came out far deeper. And so that then, the whole physicalist framework now, space-time and itself, and objects in space-time now comes into question by one of our deepest theories, evolution by natural selection. It's like stunning to me that the theory should come back, because it started off with ideas of organisms and competing for physical resources in space and time. And when we look at the structure of that theory, it tells us very, very clearly, everything that you're seeing, organisms, space and time, physical objects, that's not the truth. That's just an adaptive fiction. So that was stunning.
Now, Don, my question to you is actually now realizing all that, right? Did you have a chance to get a pushback from your parents about your point of view as it has emerged and evolved, and from your upbringing?
I did. I mean, my dad and I had conversations, and my mom would listen, and she wouldn't chip in that much, but she would listen in and support my dad. But they were very loving conversations and very, very friendly. But I was quite firm in the science and saying, look, this is. And my dad has had a master's degree in chemistry, so he understood science. But he still, said things like the Earth is only 4,000 years old, and the dating mechanisms the chemists have are must be misguided. So it was this very, very interesting combination where he had an advanced degree in science, but he didn't always go logical with it. And so we had good conversations. And in fact, I can point you to, there's online a video of us having a conversation that Dutch public television did. So they wanted to have me talk with my mom and dad about this very topic. And so there's 45 minutes or something, I've forgotten how long it is, but a conversation where we talk back and forth. And my dad talks about his religious views, and we have a conversation back and forth across. My own attitude is science and spirituality both have a piece of the puzzle, and both have misconceptions as well. And what we have to do is to not just have these barriers of science versus spirituality, but rather to go in and have some humility and openness on both sides in terms of what assumptions, what beliefs do we have that might not be quite supportable, and what are the key assumptions that we can run with. And I think that there are problems on both sides and pieces of the puzzle on both sides. And so it's not trivial to sort it out.
Yeah, it's the blind man and elephant problem, right? We don't really know whether or not it's an elephant and how the elephant looks like. So you have science on one end, and spirituality on one end, and other traditions on the other end. Don, what I'd like to do, if it's okay with you, since many of the people we know are clamoring for some structure and some simplification so they could actually grab the gist of what you're saying, because I cannot explain to them the way you could, right? If it's all right with you, I'd like to start by building something that we could tear down.
Okay.
So first, I'd like to discuss with you the Physicalist Framework, or the local realism, as you call it. And then I'll ask you a few questions about that. And then let's tear it down with the Epiphysicalist, or the conscious realism framework that you have. And then from there, let's go to the implications of your work on psychedelics, spirituality, on consciousness itself,
Okay.
right? And the utility, right? The utility to us being in this matter form,
Very good.
which is illusory, as they say in spiritual
Right.
traditions.
Right.
So let's get to the physicalist framework that we can tear down. It's like in our standard model, what this is physicalist now. So what are we ultimately made of? You know. We can go to quarks and leptons, and then what, right? So
Right.
in health optimization medicine, which I started, right? We started it with organs, right? Because that's the foundation of disease.
Right.
And then what I said over the time that technology developed, and now we can take a look inside the cells. We're able to test metabolites inside the cells. And so why don't we bring the level of medicine down to the cell and its networks, right? And now we have the foundations of health, the fundamentals of health, right? Because the cells are ultimately form all the organs in the body. It's not the fault of illness medicine that we're focused on organs. Is because the technology developed first, and of course we're the repair kind of people, right? With you, COVID hit the heart.
Yeah.
For some people it hits the brain, and so on. So, but no one takes care of the basic cell. The nucleus, the cytoplasm, the mitochondria, and the microtubules. Les Hammeroff and Penrose will kill me if I didn't say that. And so we go down lower, and we're down to the level of atoms and molecules. Now we're looking at the speed of mitochondria as they shine light on them, etc. So on the standard, just briefly summarize for us the standard model in physics that we have now, and then going down to the new theories of the quantum field theory, and then we'll erase this altogether.
So I would first distinguish between physicalism and science. So physicalism is just one theory and one framework within science, and science itself is a process of building theories, getting data, and destroying theories and creating new theories. And so physicalism,
the scientific method,
the scientific method, exactly. In physicalism, so I wouldn't want to identify physicalism with science. I would say it's been the dominant scientific theory for quite some time.
I see.
But so until recently, the physicalist framework was that space-time is fundamental, and that its particles are the fundamental objects in space-time. So quarks, leptons, and bosons is our current model. Before, it was the periodic table. Before that, it was earth, air, fire, and water, right? It was sort of the...
Right.
So we've gone through this progression: earth, air, fire, and water, the Mendeleev's periodic table, and now quarks, gluons, and bosons.
Things we had to memorize, right? The periodic table.
And these fundamental particles are mathematically defined as representations of the symmetry groups of space-time, something called the Poincare group. So particles are these irreducible representations of the symmetries of space-time. So that's been the framework. And for those studying consciousness, so in cognitive neuroscience, artificial intelligence, computer science, and also philosophy of mind, most of my friends and colleagues in these fields who are studying consciousness are physicalists, in the sense that they assume that space-time is fundamental and that elementary particles are fundamental, and they either try to reduce consciousness to physical processes, maybe complex ones in the brain, or functional aspects of those processes, so that you could build a computer AI system that has that right function in it. Some of my colleagues are try to identify consciousness as sort of the heart of particles. So each particle, in addition to its laws of physics, actually has at its core is a conscious experience. This is called panpsychism. So panpsychism, like Philip Goff and others who are into this theory, are saying, look, we're going to take the fundamental particles that physics has given us and all the laws, but the laws tell you about the interaction properties, but they don't tell you what it is that's interacting. What is the heart and soul of what is the essential nature of these particles? And so they put consciousness in at the particles. And then there are those who just say it's physical and nothing else, and the idea that we are conscious is an illusion. So these are the illusionists, and Keith Frankish and Dan Dennett take this point of view. So it's just physics all the way down. And then there are some dualists, not too many, but Eccles and Popper, for example, are famous for being dualists, where they have two ontologies, two ontologically fundamental things. There's space-time and particles, and then there's also the realm of consciousness. But what's remarkable is evolution by natural selection says space-time is not fundamental. And therefore the particles, see that these fundamental particles are just representations of the symmetries of space-time. That's what they are. So the particles aren't fundamental either. So evolution is saying that whole framework is wrong. But of course, the natural rejoinder is, hey, look, that's one thing for a cognitive scientist to be saying space-time isn't fundamental, but this is not your bailiwick. That's the bailiwick of the physicists. And they, I'm sure, have something to say about that, and they'll put you in your place. Well, it turns out that the physicists have an even stronger case against space-time. They're stronger, perhaps, than the one that I've got from evolution by natural selection. They're saying that space-time is doomed, and that's a quote. So Nima Arkani Hamed, Ed Witten,
Yes.
and others are saying that space-time is doomed. David Gross. And they have very, very clean arguments that show that the very notion of space-time has no operational meaning when you go below a certain small scale called the Planck scale. So
Yes, you're famous for saying that, less than 10 to the minus 33 centimeters and less than 10 to the minus 45 seconds, right?
43 seconds.
45 seconds.
43.
The interface, the space-time interface, to use your term, breaks down. And then there you find, structures like Amplituhedron, the Amplituhedron, and the cosmological polytopes, and so on. I only was able to understand Amplituhedron. I haven't taken a look at cosmological polytopes at all, right? But looking at that and the mathematics being clean, right? In that, and so we're saying now that we're proceeding from all this matter and then all these particles, and then we go at a certain Planck length and time, and we discover that it breaks down, and we have these other things that we find. Right? What are the implications of finding these structures? That are beyond space-time.
Well, it's quite fascinating that the physicists knew for quite a while that space-time could not be fundamental because of problems with measuring things at small scales like the Planck length. And you would create black holes if you tried to do it. So it has no meaning, but they didn't really know where to go. I mean, so space-time is doomed. What do you do, right? How do you find something? How do you peer beyond space-time? What flashlight can you use to peer into the dark beyond space-time? But they got some hints. In 1986, some guys found this new formula for scattering processes. 2 gluons hitting each other, 4 gluons go spraying out, like today in the Large Hadron Collider. And if you do it in space-time, using Feynman techniques and so forth, it's literally billions of terms and hundreds of pages of algebra to compute the amplitude for one event. And when you're trying to do millions of these events, to get rid of millions of these events per second, that's prohibitive. So the empirical theorists, the empirical physicists who were doing the experiments, asked the theorists to make the mathematics simpler. And so Park and Taylor, in 1986, boiled it down first to 9 pages, which was amazing. And everybody go, wow, that's. And then they guessed a one-term formula. Based on all the work, they had an intuition. They guessed this one-term formula, and it turned out to be right. So billions of terms reduced to one-term formula. You could compute it by hand. This was a hint. Okay, when you do things inside space and time, the math is really ugly, and there's this deeper realm. Maybe there's this deeper realm in which, once you understand what's going on there, things get simpler. So they didn't know if that was a one-off, but over the next few years, they found more and more of these formulas. And finally, in 2012, 2013, Nima Arkani Hamed and his collaborators put together a lot of these results into a single structure that's like a geometric structure. It's called a polytope. They call it the Amplituhedron. And it's just the static structure that is outside of space-time, but its volume codes for the amplitudes, and its phase structure codes for the properties of space-time, like Lorentz invariance, Einstein's theory of space, flat space-time, and also unitarity, which is the heart of quantum theory. So effectively, you let go of space-time, you let go of quantum theory. So you let go of quantum theory, it's not fundamental. You let go of space-time, it's not fundamental. You go deeper to something completely outside. You find these polytopes, like the Amplituhedron. The phase structure it projects down to those neat properties of space-time, and its volumes give you the scattering amplitudes. And it does two beautiful things. It makes the math for computing the scattering amplitudes so much simpler, from billions of terms to one or two or a handful. And second, it reveals new symmetries of the scattering processes that you can't see in space-time. So when you let go of space-time, the math becomes much easier, and you open the door to new symmetries that you couldn't see before. This is a big clue that we're onto something really special. But so that's really been exciting, because they don't know what these structures are about. So here we are. Here's this thing, the Amplituhedron, or the cosmology. Who ordered that? What is this thing? It's just sitting there. There's no notion of process. It's just this object, but it's just saying there's all these beautiful symmetries. The math is simple. Look at me. But we don't know. The physicists don't know what is that about. Now, what's really interesting about these structures, like the Amplituhedron, that the physicists are stunned that basically all of the physically invariant information that's coded in these structures is completely captured by something called permutations. Like if I have three numbers, 1, 2, 3, and it's just as simple as how many different arrangements could you have those numbers? Like, well, they could be 1, 2, 3, 1, 3, 2, 2, 1, 3. But there's always going to be, for n numbers, there are n factorial. N times n minus 1 times n minus 2 all the way down to 1. So that's n factorial. N factorial orderings or permutations that you could have. And for some weird reason, the physically invariant information in the Amplituhedron is captured by permutations. So, okay, so here's this structure, and it's just sitting there. There's no notion of process, and it's saying permutations are the heart and soul of the structure. And the question is, permutations of what and why? What's being permuted and why? So this is where the physics is. These guys are geniuses. They're using mathematics as the flashlight into the dark. Really brilliant. So, and I should point out what's really important about science here. This is really critical thing about science. What scientists did was they took our best theories of space-time and gravity, and they pushed them to their limits. And the very theories of space-time and gravity are the things that told them that space-time itself is not fundamental. That's the beauty of science, is that we take our theories and they tell us when the theory stops. And they say space-time goes only so far and no further. It goes to 10 to the minus 33 centimeters, 10 to the minus 43 seconds, and then it stops. And now you've got to look for something deeper than space-time. But the theory doesn't tell you where to look, right? The theory doesn't say, this is the new. So our theories just say, so the power of science is the theories tell you their limits. But then you have to be creative and make a leap to get a deeper theory. And that's what the physicists are doing. So Nima Arkani Hamed, Ed Whitman, and Juan Maldacena, and Benicasa, a bunch of these guys are now doing this. But here's the thing. It's not that anything goes, right? So space-time is over, so forget space-time, we'll just do whatever. No. Everything that we learned about space-time is completely relevant, because whatever new structure you get beyond space-time, you must project it into space-time, and you better get back the theories of space-time that we know and love, including quantum field theory, Einstein's gravity, and also evolution by natural selection, or even more full theories, but they cannot be less. You either have to explain what we had or more within space-time. But if you can't do that, then there's no reason to listen to you. So whatever you do outside space-time, everything that we learned inside space-time is still relevant to testing your deeper theory. So that's where the physics is. But notice that my colleagues in consciousness research don't know this yet. So that's the issue. So researchers in cognitive neuroscience, philosophy of mind, and artificial intelligence aren't. Some of them may know that space-time is doomed, but they haven't integrated that yet into their work on consciousness, because all of the theories right now are starting with particles inside, space-time, and
Yes.
like the panpsychist, like Philip Goff. I mean, in conversations with him, he's argued, well, Don, you shouldn't have consciousness beyond space-time. That's too much work. Look, just put the consciousness inside the particles. So there's these gluons and leptons and so forth. So put the consciousness inside there and just keep the laws of physics. But what they don't understand is that whole game is not fundamental. The physicists have told us the particle game inside space-time is not fundamental. You might as well be dealing with putting consciousness into earth, air, fire, and water. It's the wrong framework. So
Right. It's the other way. You're proposing the other way around,
right.
right? So now that you've broken, what is the universe? What are we ultimately made of? And we're down to breaking down space time. Now break down for us from the physicalist model down to your model of conscious realism, the origin and evolution of the universe, right? And the origin and evolution of life, right? Because those are very strong. I must admit, Don, I read your book twice because it was some heavy hefting that you were trying to do in there. Plus the fact that I had to totally reverse my point of view.
Oh,
right?
wow.
So consciousness first, right? Consciousness first, because when my journey to consciousness was simpler than yours. I entered into the lab, a medical informatics lab. My mentor was Bill Yamamoto, the guy who pioneered the entire field of medical informatics, who was a fantastic mathematician. Shoved me into topology and all of that. When you're talking about Hilbert spaces and all that kind of stuff, it's like, okay, I get what you're saying, but I'm a physician, so. Um, so the thing that I was doing was I came from the opposite point of view, right? I did the connectome for C. elegans based on the work of Sidney Brenner,
Yes.
and and there I actually wanted to remove the networks that's for feeding, for mating, for locomotion. And I was looking for something that says, now I feed, now I mate, now I move, right? And I couldn't find such a thing. So I said, well, this must be consciousness must be an epiphenomenon. And then, the challenge, there was still a Pittsburgh supercomputer back then, right? Back when they were big structures. And I was actually asked, since it said 300, C. elegans is 302 neurons, like make cellular automata out of each of the nerve cells and see whether or not you can get emergent phenomena, right? And then, so this is all in the physicalist framework, right? So my journey into this has been from that angle. And so when reading your work, and I said, well, there must be something deeper than this. And so I dove into panpsychism, which actually gives particles some causative power, right? And then you go and said, no, they have no causal power. That's just an epiphenomenon of the consciousness itself. So now, given that journey that I had from turning from a consciousness as an epiphenomenon to actually the very foundation by which everything that we know exists, right? So go through us for the origin of the universe and origin of life on Earth, and the beautiful messages and signals in evolution that gave us clues, to the fitness functions, which I think are important for people to understand. That your simulations, for
Mhm.
example, if you could go through them, that where people who saw reality as it is, the entities that saw reality as it is actually went into extinction, and those that only saw fitness function actually survived. So those are beautiful for me. Those are beautiful pieces of work that I really admire. Can you please go through
Sure. Yeah,
them?
I'll start on the evolution stuff, then I can go on to the consciousness beyond space-time kind of idea afterwards. So on the evolutionary work, one of the key things is to understand that evolution by natural selection is a mathematically precise theory. So we all know intuitively, Darwin's idea about variation, retention, and selection, but that's been turned into mathematics. And so what I and my students did was to use that mathematics first in simulations. So we used these little genetic algorithms, for example, to run simulations. We also just ran evolutionary games as well. And what we found, so this was not a proof. This was just me and my students trying to see what's going on here, right? And in 2010 or 2011, we published a paper in the Journal of Theoretical Biology, which is one of the major journals in this field, where we showed the simulations that were the organisms, the artificial organisms that didn't see reality were routinely whipping the organisms that saw the truth. So this got my interest, right? This was quite interesting. So I went to a mathematician, Chetan Prakash, and we worked on this together with Chris Fields and Manish Singh and Robert Prentner and Kyle Stevens and so forth. But Chetan is the real heavy lifter, I'll say, on the mathematics, and came up with a series of theorems, basically. So this is not just the simulations; it's the theorems that basically say that seeing the truth will drive you extinct when you compete against organisms that are just tuned to fitness. And let me immediately address two objections that people bring up all the time about this. So one objection is, well, look, if you're saying that evolution by natural selection will shape us not to see the truth, then, well, how about the mathematical truths that we see? And if you use mathematics to show that we don't see the truth, then aren't you self-refuting? Okay, so that's one of the arguments that we get. And the answer is, and by the way, something like this has been used by Alvin Plantinga as a defense for Christianity and against evolutionary ideas, where he argues that if evolution were true, none of our cognitive capacities would be reliable, and therefore our theory of evolution would not be reliable, and so it would be self-refuting. And my attitude is our theorem only applies to sensory systems, period. If you want to deal with mathematics, that's a different cognitive capacity, and you need to have a separate analysis of the implications of evolution by natural selection for that. And there, it's pretty clear that there will be some selection pressures for some mathematical prowess. An organism that knows that 2 bites of an apple gives it more fitness payoff than 1 bite of an apple is going to do better than an organism that doesn't understand that in practice. And so there will be some selection pressures for some modest ability in mathematics. I'm not saying that there's selection pressures to be a genius. Most of us have a hard time balancing our checkbooks. But every once in a while, the genes come together and you get a von Neumann or a David Hilbert and so forth, some mathematical genius that we all just go, how'd that happen? So this is not self-refuting, and I'm not giving Alvin Plantinga's argument for Christianity. I'm saying this is a specific mathematical result for one specific capacity, namely sensory systems. And it's a universal theorem that no sensory system has ever been shaped by natural selection to reveal any aspect of objective reality except the measurable structure of objective reality, because that's required by any scientific theory. So that's the first place to start. So it's basically if you take evolution by natural selection seriously, and the reason I do, and I should say another thing about my attitude, I am not doctrinaire about scientific theories. I'm not doctrinaire about my own theories. I don't believe my own theories. I don't believe any scientific theories. And any good scientist would say belief is not what we ask. What we ask is careful study and careful analysis and careful use of these theories. That's what we ask. Belief is probably an impediment. Because what we're at is to find out as quickly as possible the limitations of our theories so we can go on to the next theory. There is no such thing so my attitude is there is no theory of everything in science for a very simple reason. Every scientific theory starts with certain assumptions. And then it says, if you grant me these assumptions, I will explain all these other wonderful things. But it doesn't explain the assumptions. And you say, well, but I'll get a deeper theory that explains those assumptions. Great. but your new theory has its own assumptions, and this goes on ad infinitum. So
Isn't just
yeah.
sorry. I would just want to interject here something of a joke where there was a physicist and an economist in a desert island, and said, well, and an engineer in the desert island, and there was a can of food in there, and they were so hungry, and the physicist said, well, you could put this under the sun and the heat will burst it and we can eat something. And the engineer said, no, we can just stomp on it and it will open up and it will yield it. And then the economist says, first assume a can opener.
Right.
First assume a can opener.
Right.
So anyway, it just reminded me of
It's funny because I come in a background of economics, so I have to
right. Yeah, exactly. That's right. So the thing about science is we demand that our theories be mathematically precise, that they make testable predictions. We don't demand belief in the theories. In fact, the best scientists are looking to break the current theories and come up with the new ones. So when our best theories, the pillars of modern science, are evolution by natural selection and quantum field theory with Einstein's gravity. Those are the two big pillars. There are many other wonderful theories, but those are the big ones. When both of them are saying space-time is doomed, they both agree on that. That's pretty important. This is time for us to, Earth, air, fire, and water are not it. The periodic table is not it. Well, now quarks, leptons, and bosons are not it, and space-time is not it. There's something deeper. And so now the hunt is on for something deeper. And the physicists have found something deeper, the Amplituhedron, for example, but it's just sitting there, this static geometric object sitting there with all these wonderful properties, symmetries and simple computations, saying there's some gold here, but what is that gold about? So now I'm coming at things from a different point of view. I'm saying, okay, I'm interested in consciousness. And all of my colleagues, almost all of my colleagues, are trying to boot up consciousness from particles in space-time, either from collapse of quantum states in microtubules or from neural systems like global workspaces, neuronal global workspaces.
Yes, can you? I actually wanted you to discuss this a bit. I'm only familiar with the two ones that are competing right now for the prize, the integrated information theory and global workspace theory, for which are physicalist
Right.
models. Can you just elaborate on those a little bit, and
Right.
then go and decimate them?
Right. So I'm in fact good friends with people who are doing the integrated information theory, and they're friends of mine, and so forth. So there's nothing personal. We're all interested in understanding consciousness, and I'll be the first to admit that my theory is probably wrong, and I'm looking to beat it. But the problem with IIT? So IIT says that there's this: if you have a physical system with the right kind of causal complexity, and they measure this amount of causal complexity with a mathematical thing that they call phi, then that physical system is conscious. Now, in talking with them recently, I was just at a conference, a workshop a few weeks ago, talking with some of them. They're not really committed to a particular ontology. They might waffle on whether they're physicalists or not, or they're panpsychists and so forth. But still, the idea is that. And I asked Giulio Tononi, who's the first author of this theory, a few years ago at a FQXI, a physics conference in Banff, Canada. I just asked him in a public forum. So if right after the Big Bang, when particles are just spraying out, was there any consciousness? Because there was no integrated information. And he said, no, there's no consciousness. So clearly he was thinking that the physical stuff is fundamental, and only when the physical stuff gets the right kind of causal architecture, the right kind of informational causal architecture, that consciousness would emerge. Now he and his team may be reconsidering that, and perhaps partly because of the idea that space-time is doomed. But my attitude is still, if you're trying to tie consciousness to some particular kinds of causal architectures, it's still a functional view of it somehow. And they have all these principles that they propose. So to the extent that they're assuming that space-time is fundamental, it's doomed, right? Because and to the extent that they want to say it's not, that they're not using the physicalist framework, then they need to articulate what their framework is, because they have not. Now, the global workspace is very much a physicalist framework, right? It's brain activity of a particular kind of, and in the global normal workspace, and more generally, you could have an AI with the right kind of architecture, and whatever is doing in the working memory that has the right kind of broadcast architecture would then somehow give rise to consciousness, or the illusion of consciousness. So, Keith Frankish and so forth would say it's not real consciousness, but the illusion of consciousness. But what's really going on here is that I would say 99% of the theories and the theorists, and many of them brilliant and good friends of mine and colleagues, they all in some sense assume that space-time is fundamental. They assume that the elementary particles of space-time are fundamental. And so when our best science tells us that space-time is doomed, those theories are also doomed. And so I've been trying to talk with my colleagues, and because they're brilliant. But it doesn't matter how brilliant you are. If you're trying to boot up consciousness from earth, air, fire, and water, you could be an IQ of 300. It's not going to happen. I mean, you can't, because it's the wrong framework. And now we know that elementary particles are the wrong framework. They're just the representations of centrifuges of space-time, and space-time is doomed. So that's why we have to start over.
Dr. Hoffman, can you, there are formal names for the theories that you've proposed, and I would actually put them out there, like the multimodal user interface theory of perception, or the interface theory of perception, and of course, conscious realism. Can you, just summarize those for us, and how those two actually, now gave you the work, as you were saying earlier, now working on a paper, right? And it's now called conscious realism. And I would be so excited to hear about that. But can you just tie these together and give us the theory, that we can actually have a, it's having a handle on a name. It's like witches, if you know the name, you can curse, you can put a hex on it. So it's like, these are the formal names of the theories. And if you could just give us a rundown of those, it would be a good summary for, people who are listening.
So the task is an interesting one. Space-time is doomed. All current theories of consciousness, 99% of them, are formulating consciousness this way. They're saying, what properties of space-time, what properties of neurons or causal architectures could give rise to consciousness? That whole way of questioning is now beside the point, because it doesn't come from space-time, it doesn't come from... So all those theories are actually in the wrong space. So we now have to think differently. How do we get a theory of consciousness outside of space-time? That's the challenge. So what you have to do, you can't say, well, these properties of neurons might cause consciousness. That whole approach isn't there. So you have to actually say, I want a theory, a mathematically precise theory of consciousness on its own terms. Consciousness, qua consciousness, not as having arisen somehow from this physical property or that kind of dynamical system in space-time, on its own terms. So now, as a scientist, what you want is the minimal set of assumptions. You don't want to put a lot of assumptions on the table. You want the minimal set of assumptions that you think will allow you to use mathematics to then boot up the rest of all the beautiful phenomena of consciousness. So if you think about it, there's lots of things that consciousness is involved in. There's learning, memory, problem solving, intelligence. There's the notion of the self. There's qualia. There's free will. There's action. So what are you going to...
And that's just the human part of it, right? That's the human part of it. There's also the Big Bang, evolution, the origin of life, and all of that stuff.
That's right. So what are you going to pick? And so what I picked was only two things. I picked that there are conscious experiences. So that's one of my miracles. Conscious experiences exist. And so I can write down a probability space of conscious experiences. And second, that conscious experiences affect other conscious experiences probabilistically. Those are my two assumptions. So I write those assumptions down with Chetan Prakash and Manish Singh and Robert Prentner and Chris Fields and my collaborators. This is not just me. In fact, if anything mathematical, then you can bet that it's not just me. I have to work with smarter people than me. So what we've done is we have this simple structure that we call a conscious agent. And it's really simple. A conscious agent has a set of conscious experiences, a probability space of conscious experiences. And based on those, probabilistically, it has a set, it can take certain actions. But all those actions do is change or affect the probability of other conscious experiences of other agents. That's it.
Is part of the miracle the qualia of the experience?
Yeah, so that's an assumption of the theory. So by definition, assumptions are the miracles. So my assumptions, my miracles there are qualia and probabilistic relations among qualia. Those are my two assumptions.
And what is being exchanged between conscious agents? Or you're famous saying that there's a single, a conscious agent, and there are portals to this, and it's actually quite interesting because when looking at I heard you discuss a little bit about psychedelics and how they might modify this exchange of experiences, right? Or your perception of experience, and you actually said something very funny. So maybe you don't need psychedelics. Maybe you just need to reproduce, right? And then
We'll open the portals
in consciousness. But from that theory of conscious realism, can we have a definition of consciousness? Can we? Because we're throwing, it's like happiness. So we don't really know what it is, but we know it when we feel it or something like that. But so can we have a formal definition of consciousness mathematically, and a definition of consciousness from the, a physicalist level? Mark Solms has proposed, reticular activating system, etc. Like the first time my mentor asked me, he's like, "What's consciousness?" I said, "That which goes." Mentor asked me, he's like, "What's consciousness?" I said, "That which goes away when you sleep or when you're under anesthesia," right? You defined it by the negative, and that's very physicalist. Of course, we're clinicians, and therefore we abide by those definitions, right? But in the conscious realism,
right. So
how would
this is what science always has to do when it's trying to get a formal theory in a realm. So think about what we had to do about space. If I said to you 300 years ago, "See all this space around you? I would like you to give me a mathematical theory of that." You go, "Okay, well, how in the world am I going to put numbers on space? What do I do?" Well, finally, we came up with these Cartesian coordinates and Cartesian coordinate systems, and we got Newton. But then we found out that model worked pretty well. That was a good mathematical. By the way, that model of space is not space. Space is whatever it is. The mathematics of Cartesian coordinate systems is just the mathematics of Cartesian. So we shouldn't mistake our theory for the thing that we're building a theory of. And eventually we found that mathematics isn't right. We needed to go to Einstein's theory of special relativity. And now we realize that space-time itself is doomed. And so the scientific theory is just a map. It's not the territory. And my attitude is, as I said earlier, that no map will ever completely understand the territory in principle. In fact, I think in principle that scientific theories will always and only scratch the surface of reality. That will know.
And is it because this is the interface that is provided us?
Partly
probably
that, but it's deeper than that. It's really Gödel's incompleteness theorem. Gödel's incompleteness theorem basically says if you have any formal system that's powerful enough to do arithmetic, I'll give you a statement that's true but not provable within your formal system. And our scientific theories, our good ones, are formal systems, right? And they have the power of arithmetic easily. And so it means that our scientific theories, there will always be a truth that's not provable within your system. So now you add it to your scientific theory. Now it's one of my miracles. Well, now Gödel says, well, here's another one. And that process is endless. So I take Gödel's incompleteness theorem to be a nod to scientists saying, be humble. What you're doing is wonderful. We need scientific theories. It sure beats being dogmatic. So we don't need dogmatism. We don't need just people saying whatever they want. We need scientific theories. We need the rigor, and we need experimental tests. But then we also need this humility that says whatever reality is, I'll put it in a positive way. This is infinite job security for scientists. Infinite job security. So our exploration is never done. So this is good news for scientists. The job will never be done. And in fact, what your seniors have done is only the baby beginning. And you have the chance as a new researcher to open up new vistas, and that will always be the case. So my theory of consciousness is not consciousness. Just like the mathematical theories of space-time are not space-time. They are just theories of space. So when I write down a mathematical structure and I say this is a conscious agent, it's what I'm trying to do is be precise, and my definition of conscious agent is not trying to be like the definition of the deep one conscious agent. I didn't feel like I was smart enough to do that, and I think there's principal reasons why we might not be able to do that. Again, the Gödel kind of reasons. But so what I'm doing is this with my team. I have this theory of essentially finite agents, right? Not infinite agents. And I look at their dynamics of interaction. And it turns out when I do that, when agents interact, they actually satisfy the definition of one agent, and so they are one agent. And so I get this theory of how agents combine. And then just 3 or 4 weeks ago, I discovered that the mathematics also said they not only combine, but they can actually fuse. I can actually take agents with different experiences, and they can literally fuse identity. So again, this is something I didn't predict. It's the mathematics sort of that I wrote down with my team came back. It took me it took me 8 years to see it. So it's not like I'm some genius. I mean, it was sitting there on the table for 8 years before I saw it. So I want Johnny come lately. But about a month ago, the mathematics sort of finally hit me on the head and said, look, conscious agents not only combine, but they can fuse, and the qualia can fuse. But now here's why the deep question you asked about the one agent. When agents combine, they do form new agents. But now, when I look at the mathematics, there are so many ways that they can combine. Infinitely many ways that they can combine. But it's not just infinitely many. It turns out, as you probably well know, we have what we call Cantor's hierarchy. There's not just one kind of infinity. There are an infinite number of infinities, each one bigger than the other. And so my take right now, looking at the mathematics of consciousness, is I start off with these small agents, but when I start looking at how they combine, and then those things combine, and the combinations combine, and the math says, yeah, but that's still another agent, and it keeps going. My guess is I'm going to be going all the way up the Cantor hierarchy, and so that's well beyond my pay grade. I mean, so that's maybe mathematically how the theory is coming back and saying your theory of consciousness will never be the final theory, and here's why: because you can never find out what the final combination is. You know that in some sense it's pointing to one final combination, but you'll never be able to grok it.
Right.
So but see the beauty of science. The precision itself pushes me away from dogmatism. It pushes me away from saying, got it, nailed it, this is the final theory. No, the mathematics comes back itself and says, you're going to be exploring this for a long time. You look at this combination, now this next level of combination. Now you're at these steps of the Cantor hierarchy. You know how many more steps there are? Good luck. There's always going to be more to explore. And that may be the deepest insight about the nature of reality, that it transcends any theory.
Now, and but this we're clinicians, and you're talking about us here. We're having a grand time discussing about this. And one of the questions that I used to pose to consciousness researchers is biological life necessary for consciousness? And yours actually says, well, that is just an epiphenomenon. It just arises out of consciousness. And so it's neither here nor there. That's just life. And so there are, as you said, there are things that are useful about the physicalist framework. And but ultimately, I'm looking at, what are we actually looking at in terms of the implications of this, in the future for what we do. As you said, the playground for the space-time has been Einstein's and Bohr's and everyone else's, and the young generation is now here beyond space-time. And so what are the implications for us, the utility for us for doing that? And the thing that I wanted to ask you is, like, I know that you meditate every day, and you have practices that actually are considered spiritual by people. And how does your theory interface with the spiritual teachings that out there? Not the trash ones. We don't know what the trash ones are. I don't know what the trash ones are, but at least something that resonates with your theory as a whole. Like, for example, the ground of being, for example, that's being taught, or in meditation. There's a book by Leo Hartong on he said, I am the space where all the stars and planets reside. And I said, that's still space. So can I use Sam Harris's term condition? I am the condition where all the stars and planets reside. Probably it's more correct, right? So I'm just asking you for what are the implications to us, in terms of our spiritual practices, in terms of what we are supposed to study, and how useful is this
Right.
now
So,
going
yeah.
forward, right? For us
First,
as a
I should
species.
say, where does space-time fit in now with this consciousness theory? And basically, space-time is just a user interface
Right.
that some conscious agents use for their interactions with other conscious agents. So right now, for example, I see your face. And as I look at your face, I get some indications about your conscious state. Are you interested? Are you bored? Are you excited? Are you hurt? What's going on? I get some real information about your consciousness. When I look at my cat, well, I'm getting less information about consciousness, but some. I know that it likes certain treats and not other kinds of food. When I get down to an ant, I'm much less insightful. A microbe, I'm giving up. And when I see something that I call a rock, I have no insight into consciousness at all. But no surprise, a user interface, that's the point of an interface. It's simplifying and dumbing things down. So what this means, by the way, is that the distinction we make between conscious and unconscious objects, and also between living and non-living objects, is not a principal distinction. That is not a fundamental distinction. That's an artifact of the limitations of our space-time interface. So that's one important lesson that comes out of this right away. In science, we assume that we're trying to get this fundamental definition of what's the difference between living and non-living. And my colleagues are trying to get a definition of what are conscious and unconscious systems, like integrated information, for example. And what integrated information theory may be doing, for example, it's not telling us the absolute nature of consciousness by no means, but it may be telling us what features of our interface are giving us a portal into consciousness. So right now, I'm seeing you guys on my laptop. Well, what am I really seeing? There's a bunch of pixels. Some of the pixels are pixels associated with your face. Some are pixels associated with the board behind you. Well, the pixels on the board, for the board behind you, not doing too much. So, but the pixels on your face have pretty complicated things as you talk and move. They're doing pretty. So I'm going to have more integrated, whatever my measure of complexity is, there'll be more complexity with your face and what it's doing than, say, with the background. And so I'll have those pixels, by the way, that are for Ted's face or Boomer's face. Those pixels are not conscious. They're not alive. They're just pixels, but they're a portal. Those are the pixels that are a portal into Ted's consciousness and into Boomer's consciousness. You can see the portal metaphors. They're not literally, but they're an interface portal into your consciousness. So that's what space and time is. It's giving us an interface for certain conscious agents into the consciousness of other agents. And first thing to say is space-time must be one of countless different kinds of interfaces. This is not the only one. There's got to be countless other kinds of interfaces. Why shouldn't we be able to imagine things in 5 dimensions or 50 dimensions? Why shouldn't we be able to have 30 dimensions of color instead of 3? I mean, often when I'm thinking about this, I realize, boy, I'm really in a perceptual and conceptual prison. Try to think about 4 dimensions. Can't do it. Try to think about a color you've never seen before. Can't do it. My limitations are right here in my face. It's just truly stunning. So I'm really limited. But now
the deeper question is, probably has no answer, right? But why are we in this? Why manifest at all, right? Why have this interface at all?
Right. So if consciousness is fundamental, what is it doing and why? And of course, the right answer is I don't know. But as a scientist, what I want to do is to propose theories that I don't believe, but that I think are deep enough to be a fun next step for us to pursue. And so the only idea I've run across that I think is deep enough to at least be a starting point is, again, Gödel's incompleteness theorem. And what Gödel's incompleteness theorem tells us is that there's no end to the exploration of mathematical structure, in principle, no end. Under the assumption that consciousness is all there is, then the only thing that mathematical structure can be about is the possible varieties of consciousness. Therefore, I conclude that Gödel's theorem entails, in this context, that there's no end to the exploration of the possibilities of consciousness, in principle. And so that's a good starting point for asking, what is consciousness up to? It's up to the endless exploration of all of its possibilities. And why then are there things like Ted and Boomer and Don stuck in a little four-dimensional space-time doing what we're doing? Well, on this theory, we are all projections of that deeper one consciousness. It put on a space-time headset, and it put on it's a first-person VR. You have an avatar, and there's a Ted and a Boomer and a Don avatar, and we have gotten ourselves immersed in this VR. We've identified with our bodies. We lose ourselves. We think that we are players in a VR game. So it's very like a good VR. If you've ever been in a very immersive VR game, it's very easy to lose yourself in the game and to not have this awareness of myself as, something outside the game, but as this little guy inside the game. Well, that's what our normal condition of consciousness is. We feel like we're little creatures inside this big space-time, and we forget that space-time is just this headset that we're wearing. We're outside the headset. We just put the headset on.
That's one of the beautiful paragraphs towards the end of your book, Cast Against Reality, right? Where they were playing some game like a volleyball, and then you remove your VR suit, and actually what or who is removing that VR suit?
Exactly right.
And you actually told me at the time, it's like that was what you were working on, and that was the conscious agent theory, which we just discussed. And so, Dr. Hoffman, now that you have all of this, and then having experienced the hospitalization that you did, and then having this, it's like, what's the impact on you? You told us, like, well, we have to study everything, right, from the physicalist model all the way down, but what has been the impact on you on the theories that you have vis-a-vis what you experienced while being in the clinics, while being treated as a matter of form, and looking at the cause and effect that the physicians are doing on you?
Yes. So, and this raises also the general question of the relationship of science and spirituality as well.
Right.
So for me, this theory of conscious agents makes it very, very clear that this body is just an icon in an interface. It's not me. My brain doesn't even exist when it's not perceived. I have no brain. I have no neurons. If you looked inside my skull, you would see brains and neurons, but that's because you're creating them on the fly. Just like in VR, if I look over and see a car that I'm racing, I create the car when I turn my headset that way, and I delete the car when I look. So these things come and go as you look. So my science told me this, but my emotions don't believe it, right? My emotions are tied to my body, since infancy. And I believed in what we call object permanence, that the moon really is there when I don't look, and my body is really there even if it's not perceived. So all these things are wired into me. Why? My guess is that consciousness, when it's exploring its possibilities, it really is exploring its possibilities. It says, let me get lost. Let me lose myself and have to wake up. So we lose ourselves in the process of exploring, in this case, of four-dimensional space-time and colors and objects and so forth. And it's part of consciousness knowing itself is first forgetting itself, not knowing what it is, identifying falsely with this very, very rich universe, billions of light years across, trillions of stars. It's exotic. It's impressive. I thought I was this tiny little thing inside of it, but I wake up and realize, no, that is all my creation, and I transcend that. So it's a very human process that seems to be tied in with the whole purpose of consciousness, which is to explore itself. That involves somehow losing yourself in a myriad of possible forms endlessly, waking up and essentially knowing what I am, because I'm not just that. I'm whatever created that, and I'm deeper. And so, and Gödel, incompleteness theorem, suggests to me that that is a never-ending process, that we will constantly be exploring new and new possibilities. So it's like strap yourself in. It's going to be a fun ride, and the ride is forever. And you just it's a roller coaster, and you never know what's going to be around the next turn. And part of what's important is never get attached to the current part of the ride. Enjoy it, let it go, and get ready for the next thing, because it's the ride, not this particular scene. That's what it's really about. It's the exploration. So that's interesting.
Does that have any bearing on the Hindu beliefs on reincarnation, for example? They have a longer view that if you can't do it this time, there's another time and another time and another time. Unlike us here in the United States, where you only live once, and therefore we'll do everything right at once because we don't believe in such stuff, right? It's a long view, short view type of, and I was looking at this in terms of, what your theories were actually doing on these other beliefs in other systems, spiritual systems.
Well, so I think that that Hindu, but also any mystical spiritual tradition, so Kabbalah, Sufism, Buddhism, mystical Christianity, like Benedictine monk kind of monasteries and so forth, that kind of Christianity that they practice there, these all have something in common. There's this mystical aspect that says that there's some consciousness that's beyond space-time, that's really fundamental, and understand that you are not this little body in space and time. You really are one with that consciousness, and really perhaps there's just one of us. There's not Ted and Boomer and Don and 8 billion people on the planet and then my cat and dog. There's really one of us. And we're all different projections of that one. And in some sense, learning to love you is really loving the one that is myself. And loving your neighbor as yourself really is loving yourself. And so now the idea about reincarnation and so forth. So here's the key thing where I think science and spirituality need to interact. Spiritual traditions will say, look, we're using words as pointers. The word isn't it. The map isn't the territory. The Buddhists will say the finger pointing to the moon is not the moon. It's just a finger pointing to the moon. So that's good. On the other hand, of course, many religious groups, so I'll move from spiritual to religious. Many religious groups are well known for their dogmatism, where they take their words too seriously and they fight and kill over differences on words. So if we go back to the spiritual tradition and say, look, the words are just pointers, don't kill over them, and don't only take them as a way for you to come into firsthand experience of a thing yourself. So now the thing about spiritual traditions is we don't have a way to evolve our pointers. In many cases, we have the same pointers that the Buddha gave us, or the Upanishads gave us, or whatever. And what science can do is give us a technology and a method for evolving our pointers. Actually saying, let's make these pointers precise. And if we do that, the nice thing about it is we then know when those pointers stop. Like space-time stops at 10 to the minus 43 centimeters. We know where that pointer stops. And so that's what I see going forward.
Can psychedelics do that? Evolve your pointers?
Well, I think so, but it's not clear with any given psychedelic whether it's opening a new portal into consciousness or it's just a bang on the head, right? Like a hammer on the head, which may be doing something, but it's not really opening up perhaps a new portal. And so that I think I want to explore. So I think it's quite possible there are genuine new portals that can be opened up that way. And you asked about new technologies. I think when we understand a couple levels of description of science, of consciousness beyond space-time, and we realize that space-time is just our VR headset, we'll be in the position of like the software programmer. Like, so suppose I'm playing Grand Theft Auto with a virtual reality headset, and I'm really good at it, and I'm proud that I can beat everybody and so forth. But well, this geek that knows the software can take the gas out of my tank. He can give me a flat tire. He can turn my car and spin it around. He can do all sorts of magic that even though I'm a master of the interface, he's the master of the software outside the interface that generate. So once we get outside space-time and we start to play with the software outside space-time, we'll get technologies that will blow our minds. And one that comes to my mind is right now, most of the galaxies that we can see, we could never go to. They're receding from space-time is growing faster than the speed of light, and we could never get to them because we have to go through space-time. Well, what if we didn't have to go through space-time? What if we realize space-time isn't the fundamental reality, it's just my headset? Oh, and I know the software that's being used for my space-time headset. I would like to go to Alpha Centauri, or I'd like to go to the Andromeda Galaxy. Well, instead of going, 2 point whatever million light years through space to Andromeda, why don't I just go around space? So all of our rocket technology, all the stuff that we have to do to travel through space-time will become obsolete as we figure out how to go around space-time. It's very much like Maxwell's equations, right? Right before Maxwell, we had to take, if I wanted to talk with you, I had to go to you, or I had to give you a piece of paper or something like that. Right now, I don't know where you guys are. I guess you're in New York. Are you in New York? No.
DC.
You're DC. You're in Washington, D.C. We're 3,000 miles away. I don't have to give you a piece of paper. We can go around the paper, and we can talk directly around the paper because of Maxwell's equation. Well, with the new equations, we'll talk around space-time itself. We won't have to go through space-time itself. And that's just the tip of an iceberg once you start to think about it.
That's because space-time itself becomes just another interface.
It's just a data structure. Once we connect the data structure, we can do anything we want.
Boomer here has a dying question about, no, not dying, has a very curious question about how you meditate. Go on, Boomer.
Yeah, so Don, I guess because I want to be cognizant of your time, and I know we're running up on time here. You've alluded to before, in terms of meditation and some of your meditation practices, that they've helped you kind of grip with some of the dissonance between your theorem and living in this dimension, so to speak. What form of meditation are you using, and sort of take us through your process, if you will, just to kind of wrap up the conversation.
Right. So my meditation is with minimal structure. I sit in silence, and I don't care what position, whatever is comfortable, and I let go of thought and go into just silence without thought. And of course, thought comes back in. And when it comes back in, I notice it, don't fight it, don't beat myself up. Or if I see myself beating myself up, then I notice that I'm beating myself up, and I just watch that and let it go. And what's happening is I'm disidentifying from my avatar. I'm consciousness. I'm not something inside space and time. I'm something outside of space-time. But I'm identified emotionally and mentally and with my thoughts with this little structure inside space-time. And I'm attached to it, and I'm trying to build my reputation. I'm trying to compete with other people, all these things. When in fact, I'm not a little thing, and I don't need to compete and so forth. So what I really feel like the meditation is doing is it's basically waking me up from identifying with my avatar. And it's waking me up and saying, this is very much like if I had a friend who was playing a VR game for a few hours and they lost themselves in the game, I'd say, hey, Bill, wake up. You're not inside the game. You can take the headset off. You're outside the game. You're not some little guy. That's what meditation is really about. It's waking me up. It's saying you're not a little. So it's really as few rules as possible, but really paying attention to the emotions. Really, because when you let go, if I'm feeling something like competitive or angry or something like that, watching that and being with that and letting it, instead of turning away from it, facing it and realizing, okay, that is me attached to the simulation. That's me attached to the headset. There's only one way through that. I've got to face it and let it die. Face it and let it die. And the spiritual traditions will point to that. Jesus said, if you want to come after me, deny yourself, take up your cross daily. And that's what it's really saying is, look, you are not the little thing in the space and time, even though it feels like it. So what you have to do is just be with the little me that's trying desperately to be better than everybody else or get more of this so I can be finally fulfilled, and realize, no, that's me lost in the game. I need to get that car, I need to get that house to be good because I think I'm a little guy in the game. No, I'm outside the game, and this is just a little game that I'm playing. Once I realize that, then, so I'm in that stage where I know I'm not in the game, but my emotions don't know it, and so I'm having to patiently sit there, and I'm learning something about myself by just being very, very patient and seeing the part of me realizes it's really stupid, but there it is. It's attached, and so. And there's one other thing I'd like to just say. It's a question that comes up about this, and about the idea that consciousness is fundamental. And Philip Goff has raised this issue. So he's a brilliant philosopher of mind and a panpsychist. I think he's an incredibly intelligent guy. And he raised a very, very good question. He said, look, you've got this theory from evolution of natural selection that says this is just an interface. It's not the truth. And yet you're saying that I can see the truth about your conscious experiences by looking at you. Isn't that a reductio ad absurdum of the whole approach? And the answer is this: there's two steps. The first is take evolution by natural selection seriously as a scientist. That theory clearly entails that space-time is not fundamental. This is just a user interface. Okay, so that's said and done. Now, that's the first step. That's an interface. Nothing you see is the truth according to evolution by natural selection. It's just an interface. But now as a scientist, I say, okay, step two. What's on the other side of the interface? Evolutionary theory can't tell me. So I'm going to posit that it's consciousness. And I'm going to posit that this interface is an interface to consciousness. And under that posit, so you can see, I'm not caught in the reductio ad absurdum. I'm saying there's two steps. The theory of evolution by natural selection says it's an interface, but not an interface to what? You can only say it's not the truth. Then I get to take another step and say, okay, I'm going to get a deeper theory, where the deeper theory has to then eventually project evolution by natural selection. In that theory, consciousness is fundamental, and I'm getting true perceptions of consciousness, fallible, but nevertheless insightful. So I thought it was really important. It was really great of Philip Goff to point out what looks like a reductio ad absurdum so that people can really see the logic that's going on here and how science works, where we take our theories, take them to their limits, and then make a creative leap to the next theory. And it might look like a reductio ad absurdum, but no, that's just the way science works.
That's really beautiful, Don, because you actually answered with those two steps the formal names of your theories, right? One is the multimodal user interface theory of perception, which is everything is an interface and it's in evolution. And the second is a conscious realism. Well, let's posit
exactly
that,
right.
Everything is consciousness at the beginning. And,
exactly.
When I in particular have a name that I can handle, then it's easier to move it around in my mind. And I hope for the listeners of this podcast that they have too, in terms of being able to understand, because this is a very radical theory. As I said, I read your book twice. I've been following your work. I've been reading up on I've been watching Nima Arkani Ahmed's videos on YouTube.
Okay.
And that's from your influence.
Okay.
Long before that was much longer. It took me much longer to do that. I already had his Amplituhedron as a wallpaper, in my laptop. But this is exactly what I wanted to bring out here, is that there is now this new way of looking at things, and it deserves a study. It may not be in our generation, as you like to point out, Don, but this is the younger ones are the ones having a ball at this one, and it would have massive implications, not only as not only with the theory itself that you having, but also it also goes up right into the physicalist frameworks that we have, because then we could see the various different avenues that this particular uh, theory can rise to give other permutations of what we're doing right now in the physicalist realm. Not only in fields of engineering and so on, but we're physicians and healthcare providers, and how all of those will actually affect us in the end of how we view the body. As I said, now I'm forcing medicine to look at the body as an ecosystem of cells. We're not, a system of organs. We're an ecosystem of cells that's interacting. And you're saying, no, you're an ecosystem of conscious agents, and there's really only one conscious agent, and so on. And that's a really, really very deep leap, but it's something that we actually need to explore now. Otherwise, we'll never get into that. As you said, all of these brilliant minds that, you just, make them face in the right direction. Sometimes they will see something that's totally beautiful that you've never seen before.
I can't wait to read their papers.
So, Don, look, it's been an incredible time with you. I know we're coming up on time, and first, thank you so much for everything that you've contributed.
Thank you.
We're really, really glad that you've made it through COVID.
Thank you. You too.
We'll link to mine. It sounds like was a lot more, I guess you could say, mute than yours. But thank you again for taking the time to be with us here today. We'll link to the book and a number of your papers in the show notes. But where can people find out more about you, Don?
Well, I have a Twitter feed, so people, they want to see my podcasts and books and so forth. It's at Donald D. Hoffman, Hoffman. So it's Donald D. Hoffman, all one word. So I post stuff on Twitter, and I have my book. I have a couple books: Visual Intelligence, How We Create What We See, and also The Case Against Reality: Why Evolution Hid the Truth from Our Eyes. So a couple books on this. For those who want to see lots of mathematics, I've got the book Observer Mechanics. That's pretty nasty, but that's.
Is your latest paper out, Don? That you talked about earlier, or is it just about to get out?
I was writing it this morning. I'm in the process of writing. It's due. I've got a journal that wants it by August 19th, and so my team, it's where we actually have this theory of conscious fusion of qualia and of conscious subjects. So with the mathematics of fusion, and where I'm also going to be spelling out a link all the way from the dynamics of consciousness through its asymptotic behavior, describing that with permutations, and then it turns out permutations give rise to the Amplituhedron, and that takes us into space-time. So what this paper is going to try to do is start with a theory of consciousness and take it all the way into space-time. Show all the links. Of course, there's going to be a lot of work to do on all the links. I mean, this is decades of work, but you need to have this big picture first, and then you can go through. And so I have this big picture that I'm going to be putting out there, and we'll see. I'm pretty excited about it.
I'm looking forward because right now it's like, okay, we've seen the picture until conscious agents, and so on. But I'd really love to see the relationships and how it progresses. How the Amplituhedron is built, and how behaviors emerge, and how experiences are exchanged. That would be fantastic.
Right. Well, I gave a talk at a conference 2 weeks ago where I presented it to. It was a bunch of quantum theorists, and David Chalmers was there. So a bunch of. So I'll send you a link to that. So it's out, and it's going to be published. The video is going to be published pretty soon. So I'll send you that.
Very
But then, now we're doing the paper based on that talk.
Beautiful.
Okay.
Don, this is amazing. Thank you so much for the big education, and we really appreciate you coming on the show today.
Thank you very much again. It was very much a pleasure, and thank you for your kind invitation.
To everybody listening out there, have an absolutely wonderful day. Don, thank you so much.
Thank you.
All right, this has been another episode and a fantastic one of the Smarter Not Harder podcast. If you enjoyed the show and your mind was blown perhaps, can you head on over to Apple Podcasts, Spotify, or wherever you listen to your podcasts and leave a 5-star review? Every little bit helps. And while you're at it, if you're on YouTube, click subscribe because we want to hear more from you. What did we get into in this episode? Wow, so much. The Amplituhedron, of course. Conscious agents having an experience, Don's work and how he got really started in consciousness, psychedelics, and so much more. I think I'm going to have to go listen to that one myself again. If you have any further questions on this, the show notes are, of course, available on both the transcriptions as well as Home Hope websites. And thank you for tuning in to the Smarter Not Harder podcast, your home for 1 cent solutions to life's $64,000 or perhaps more questions.